Hello, welcome to my project video. As you can see, this is my current project report. My project title is Predicting Bank Defaults Using Machine Learning. As you scroll down a bit, you get a bit of an understanding of the project before going further into detail. So my project aim is to develop machine learning algorithms to be able to detect if an account is default. This is a good reason for banks to implement, because if they are able to do this and see if any accounts are at risk, they can reduce costs. Because there's a chance of that the person who owns the account could still use their credit card, costing the bank money because they won't be able to repay it. So they can close the account if they need to save money and resources that they might not have nowadays. If we scroll a bit further down, we can go to my chosen methodology, which is this nice little diagram here. This is the machine learning approach. It's a very simple methodology. It consists of 5 steps. First step is just collecting of data. Second step is making sure the data is clean of any missing values and outliers, which I have done further down in my project report. If we go down here, missing values there, and all that stuff. Go back to that. See that step 3 is the actual developing of the model, which is in my sections below, which I'm going to show you a code of it in a bit. And step 4 is the evaluation, which I used a specific function from in RStudios to be able to do it. Step 5 is model deployment, which I'm not really doing that step since this is only for education reasons. But this is where a third party, let's say, because I doubt a bank would have their own team for it, would then send the product they develop out into the industry for the banking companies that they've been hired for to implement that onto their systems and databases to be able to find if someone is at risk. So if we go to RStudio, this is my code for decision tree. It's one of the easiest ones to understand, not very complicated. It's my chosen product because it had the highest accuracy out of everything else I've seen, though they were all very similar. So this first line here, at line 12, just loading up the data set. So let's make sure it's got the right one. Oh, of course, I always forget. You gotta set your working directory to be able to actually read the files. There we go. Now we get this over in our environment, which is our account data, and it is the Excel sheet that I've just imported using the read function for all our data. Now, if we go all the way to the right, we've got default payments next month. This is our Y column. This is what we're going to try and predict. And other interesting things you could find out about the data set you've just imported is using string and summary. So summary allows you to see interesting values about like the median, the minimum, the interquartile ranges and all that stuff for each column. And string lets you see what kind of variables the columns are actually formatted in. As we can see, they're all in integer. The first major technique I used for developing this model is splitting the data. And it's pretty simple. We want it 80% to be in train, 20% in to be test. You can see the code for that in this highlighted section here. The reason we do this is to be able to actually train the model when we're developing it, so it's able to predict what we want it to predict. And then the testing is to see how good the actual prediction is. So when it comes to the test, we'll use it down here in the model evaluation. So if we just run that, we get on the right side, we get our test and train. There are the 80% and 20%. You can notice you can change this to whatever you want, but this 80 and 20% is usually the regular one. Using this, and you can change it to 70%, 30% if you wanted to. The next set of technique that I used is making sure the data are at the same fact level, because I was coming to an issue where when it came to the confusion matrix, which is this last line here, that it would not, that the variables that I was using in it would not the same factor level. The way I got around this was making sure that the programming language, knew that the default payment next month category, the Y column that we're looking for, is going to be in ones and zeros. Then after this, we got our model deployment, which is our car fit. It's just a variable name. We use rpart, which is the function that used for creating the decision trees for this particular model. If we go to like random forest, we see that we use the random forest instead. And then we got our train data. Well, we got our Y column here, which is what we're going to try and predict. Our data is the train data. And we use method class to make sure that it can predict what we need. Then if we just run that. Actually, I need to run these. Get a quick summary of all that, but we don't really, for what I'm using this for, you don't really need to look into detail for this. An interesting thing you can do with rpart is they have rpart.plot, which is another library you have to install as separate from rpart. Is it allows you to see your decision tree on the right hand side in a nice neat thing. So as you can see, it's very simple because decision tree only deals with one tree. If you're dealing with multiple trees, you would be dealing with random forest. So that's basically that. And then when it comes to model evaluation, we're finally using our test data. And then we create this new variable comparing using the predict function right here. And then we use the confusion matrix function to be able to actually get statistics for this prediction that we just made using the predict function. And if we look at this, we get an accuracy of 81.2, which can change now and again. It's not always guaranteed. And a kappa score of 0.3415, with basically just 0.3. We'll just call it that, which shows that it has some fair argument and has some predictive power. So there could be more models out there, probably hybrid models, that have a better look at what we need. Some other interesting things you could find here is like detection rate to see how much it actually has found what we're looking for, which would be the ones to see if it is account is default. So when it came to specific challenges, like I've already mentioned with the confusion matrix, I had to make sure the same factor levels were applied to both things, which looks pretty easy, but a Google search did not help. You have to really look for it. And as we can see through all these different web pages, that my knowledge from the start of this project, where I had no knowledge of machine learning models, has developed enough that I'm able to make 5 models and clean the data set. So that shows that. Another thing we have for my project is this nice little dashboard, which is just using a pivot table and a splicer to be able to filter out specific stuff. Got some simple buttons at the top to be able to see what we actually need. Big nice text for people to actually look at instead of them going through a table, because it's quite small. Plus it just looks nicer. And then we've got some conditional formatting onto the table to be able to see quite easily where the dark green is the best option and the red is bad. So we can clearly see that the sum of accuracy that I initially got was 82.07 for decision tree, which was interesting. So that clearly shows that the accuracy is the same. The best one out of the one I was initially testing. But like you would also see that Random Forest has the best Kappa score, even though the Kappa scores are very similar. That it basically doesn't mean much difference. I've got some extra graphs on there to show you some interesting stuff, like how you can see these data points onto an actual graph and see the scale of them compared to each other on a visual diagram. Got this bar chart in the side to show the accuracy of each model. You can see that they're roughly around about the same, with Rayleigh, the naive bias being miles like 10 out. But without the actual numbers, it'd be harder to tell. So I included the numbers and made them bigger, so it's easier for a new user to explore. And then we got this, which is a another chart, and it shows the detection rate, because I thought that was quite interesting, because the logistic regression came out 5.91, which isn't a lot. And if we go back to our Word document, yeah, this is the logistic regression one. We can see here that detection rate was 0.0593. Isn't too great. So another thing we can find by going into my project report, which is all available on my GitHub with the rest of the code, which is also linked in the report, is that we can see monthly reports, which basically go through everything I've done for that month and what I plan to do the next month, even to the point where like my whole project main aim changed. Another thing you can easily see in the report is my conclusion, which when it came the main aspects to take away from my conclusions and evaluations is that my methodology was good, but if I was to do something to enhance this, tuning the models would be important, and that isn't actually mentioned in the methodology I've chosen. And that the products were all very similar accuracy levels, as you've seen through the dashboard. But the main thing to take away from this is that the project was a success, and the banks could easily implement these if they wanted to, and be able to see which accounts are at risk. Then they can take the next steps from there. Maybe send a notification or an email or a letter out to the person who owns the account, telling them they're at risk and what could happen to him. So, yeah. If you want a specific link, just a bit of explaining. This is my specific link to the GitHub. It's public, so anyone could find it. And there's no hidden things or anything. It's quite nice GitHub to upload everything, because you're able to see all your commits, which also shows my time management, since I don't actually have a Gantt chart, but you can see like the earliest date of February 19th is when I actually start my product. So that's everything for my project, and I hope you enjoyed the video.